Hello everyone, this video is about kinematics of motion in a straight line past paper questions. So there are three types of questions about kinematics. The Sufat formula questions like this, the graph questions like this, and the calculus questions like this. So for the Sufat questions, you're given some variables and you need to find the missing variable. So here we have to identify what you know from the question. You have initial velocity u24, you have 5 meters above ground level, okay, and you're looking for the time until reaches the ground. So this means you need to find the time from the launch position to the ground here, which means you have the u24, the a minus 10 because u is going upwards positive, a going downwards must be negative, and the s is negative because the ground is 5 meters below the launching position. So this time we start counting the time when the object is launched. So to find the time here, we can just use this formula, ut plus 1 half at squared. You plug in everything, use quadratic formula, and of course time cannot be negative. Another example, we have initial speed u, constant acceleration a, takes 5 seconds to travel the first 80 and 8 seconds to travel the first 160. So we have two conditions here. In the first condition, we have u, we have a, we don't know the values. We know the time is 5 in 80, the distance is 80 meters in 5 seconds. And exactly the same u, exactly the same a, this time the time is 8, the distance traveled is 160. So we use this formula, s equals ut plus 1 half at squared, plug in everything, you get an equation in two variables, and same thing here, another equation in two variables. We can solve by some substitution or elimination. Here we eliminate, multiply the equation here by 8 over 5, so that we get 8u here. We can eliminate 8u, and after subtracting we can find the value of a, and after we find the a, we can use any of the equations to find the u. Here we're using this, replace the a, find the u. Now for the graph questions. So for graph questions, we need to find the area under the graph of the gradient. So here we have find the acceleration of the train during the first 40 seconds. So we know that the acceleration is rise over run. The rise is 16, the run is 40, so it's just 16 over 40. The length of time for which the train is traveling at constant speed, so it's constant speed here. Now we know that the distance between the two stations, so the whole area is 9040, and this area can also be found using the area of a trapezium, which is the sum of parallel sides. We have 600 and x parallel sides divided by 2 times the height, which is 16. So this means we can find the x, which is the time for this parallel side here. We have the time when the velocity is constant. The distance traveled while decelerating, so we're looking for this area here. We know this area because we have base times height divided by 2, we get 320, and we know the area of this rectangle because we know the x already. The x is 530, and the height or the width of this rectangle is 16. We can find the area of the big rectangle here. So the remaining area would be the total area of the trapezium minus triangle minus rectangle, and we get this distance traveled while decelerating. Another example here, given that the acceleration between t equals 30 and t equals 35 is 0.8, find the value of v. Okay, so we know that the gradient is 0.8 here. The gradient is delta v, which is 12 minus v, I mean, divided by 5. That's the gradient. So the acceleration, which is the gradient, which is 0.8, is equal to the delta v divided by 5. We can find the delta v, which is 4. So since the delta v is 4, the v must be 8, and that's the value of v, which is 8. And given that the total distance covered is in the 50 seconds of motion is 375, so 375 is the total area under the graph. You can find the area of this blue triangle, base times height divided by 2, and for this area we can use trapezium, sum of parallel sides 12 plus 8 divided by 2 times the height, which is 5, the height of the trapezium. And this is a rectangle, so the area is 8 with times 25, and if you just subtract, we get 35, which is the area here. Now for calculus questions, the particle reaches its maximum velocity. So maximum velocity means the derivative of the velocity equals 0. So v prime equals 0. V maximum is when the v prime equals 0, and the v prime is basically the acceleration, and the acceleration function is this. So when this is 0 to the power of 1/2 means square root is 0, we can find the time and find the velocity of the particle when its acceleration is maximum. So when the acceleration is maximum, a prime equals 0, so we need to differentiate the a. We have this, solve for t, we have t equals 1. So when the time is 1, the acceleration is maximum. So to find the velocity, we can use the integral of acceleration, and we have the constant of integration, and we know that the velocity initially is 1, so when the time is 0, the v is 1. We can find the c, and therefore we have the final answer. That is the v of t. Plug in the t, we get the final answer. And last example, we have the s function, the velocity, which is s prime. Actually, there is a prime here, is this, and the acceleration, which is v prime or s double prime. We differentiate again, and the a is 0 here, the velocity at the instant when the acceleration is 0. So the a is 0, but the a is 60 minus 12. We can find the t. So when the time equals 2, we need to find the velocity. We can just differentiate, we get the velocity function, 3t squared minus 12t plus 4. Plug in the t value, we get the velocity when the acceleration is 0. Alright, I'll see you again next time.